Hi, in this video we're going to talk about how to take the derivative of functions using the chain rule, but specifically when our chain rule involves the composition of trigonometric or logarithmic functions. In this video, I'm going to assume you're comfortable taking the derivatives of trig functions and logarithmic functions, so if not, I'd recommend reviewing those. So now going forward, we're just going to refresh ourselves on what the chain rule is. So the chain rule says that the derivative of g of h of x, so the composition of functions, is going to be g prime of h of x times h prime of x. So we use the chain rule when a function f of x is written in the form of a function composed of another function. Again, we have that form f of x as g of h of x. And again, when we set its derivative, we see the derivative of the outside function still composed with the inside function times the derivative of that inside function. So the inside function can be a function such as a trig function or a logarithmic function. So now we're going to go through the specific steps we're going to use. So first, we're always going to want to write f of x is equal to g of h of x. And then we're going to want to identify what our inside function h of x is, and identify what our outside function g of x is. And then we're going to compute g prime of x, and then evaluate g prime of h of x. And to do this, we're going to sub in h of x into g prime of x that we obtained in step 4. We're then going to compute h prime of x. We're going to write down the full chain rule just so we know what we're doing. So d dx of g of h of x is equal to g prime of h of x times h prime of x. And then we're going to plug in the results from step 5 and 6 into the chain rule, and then neatly write our final answer, f prime of x is equal to that result. Just a quick tip before we go into an example. While not always true, generally our inside function is going to be inside parentheses. So now let's look at this example here. So f of x is equal to tan squared 2x. So the first thing we're going to want to do is identify what our inside and outside functions is. So we know that f of x is equal to tan squared of 2x, but right now it's not immediately clear what we could use the chain rule for, what our inside and what our outside function would be. However, we can rewrite tan squared of 2x as tan of 2x, and then that entire thing inside parentheses squared. So from here, it becomes a little bit clearer what our inside and our outside function is. We see that our inside function, our h of x, our thing, as I said, inside parentheses, is going to be equal to tan 2x. And then our outside function is just going to be g of x is equal to x squared. And again, we get the x squared because we have everything inside our big parentheses I wrote squared. So now from here, the next thing we want to do is find g prime of x. So g prime of x, we can find this using the power rule. We multiply the 2 down in front of the x and decrease the exponent by 1. And we know that the derivative of x squared is 2x. So now what that means is that g prime of h of x, because again we want to evaluate g prime with h of x, is going to be equal to 2 tangent of 2x. Next, we now need to find h prime of x. So to find h prime of x, we're going to need to do a brief little aside and take the derivative of what tangent is. So remember that d dx of tangent of f of x is going to be equal to secant squared of f of x times f prime of x. So in this case, h prime of x is going to be equal to secant squared of 2x, because again, the derivative of tangent, the first piece is secant squared, and then whatever we're taking the tangent of, which is 2x. And then we have f prime of x, so we need to take the derivative of the argument to tangent, and the derivative of 2x is 2. So we get that h prime of x is going to be equal to 2 secant squared 2x. So now that we have our constituent pieces, we now could write our chain rule that d dx of g of h of x is going to be equal to g prime of h of x times h prime of x. So now we just need to multiply our two pieces from up here, and that gives us 2 tangent of 2x times 2 secant squared 2x. Or finally, for our nice neat final answer, f prime of x, our derivative, is going to be equal to 4 times tangent of 2x times secant squared of 2x. And that will be our final answer for the derivative. For our next example, we're going to take the derivative of the square root of ln of x squared. So again, first we're just going to write our problem. So f of x is equal to the square root of ln of x squared. But again, we want to try to figure out what our inside and our outside function is, and here it might not be readily apparent which is which. But what we can do is we could rewrite the square root as an exponent to the 1/2 power. So we get in parentheses ln of x squared, and then all of that raised to the 1/2 power because the 1/2 power is equivalent to a square root. So here it becomes much more apparent what our inside and our outside function is. Our inside function, what's in the big parentheses, will be h of x is equal to ln of x squared. Then our outside function will be our exponent outside the parentheses, so that will be g of x is equal to x to the 1/2. From here, we'll now find g prime of x. So we'll take the derivative of our outside function. So g prime of x we'll just find using the standard power rule. We'll take our exponent of 1/2 and multiply it to the front, and then decrease the exponent by 1. So we get 1/2 x to the negative 1/2, which is equal to 1 over 2 square root of x. And then from here, again, we don't want just g prime of x, we want g prime of h of x. So now we just sub in h of x, and we get that g prime of h of x is going to be 1 divided by 2 times the square root of the ln of x squared. So that's good, we now have g prime of x. Now we also need to find h prime of x. However, to do this, we should briefly review the derivative of a logarithm. So we know that the derivative, so d dx of the logarithm of some function k of x, is going to be equal to 1 over k of x times k prime of x. More simply stated, it's basically 1 over whatever is inside the logarithm times the derivative of what's ever in the logarithm. So here, 1 over the function would just be the 1 over x squared we have inside the logarithm, and then we would multiply by the derivative of what's inside the logarithm. And the derivative of x squared is going to be 2x. So we find that h prime of x is 1 over x squared times 2x, which is just equal to 2 over x. So now that we have h prime of x and g prime of h of x, we're almost done. We just need to finish writing it out. So we know that f prime of x is going to be equal to g prime of h of x times h prime of x. So plugging in what we already found, that will give us 2 times the square root of ln of x squared, again that's under a 1 in the fraction, times 2 over x. And we find our 2's cancel, and we're left with x square root ln of x squared in our denominator, and then that's a 1 as the numerator. So this means that our final answer for the derivative is that f prime of x is going to be equal to 1 divided by x square root ln of x squared, just like this. And that, again, that is our final answer. For our final example, where we have that f of x is equal to sine cubed of ln of x. So this one's a little bit more complicated, but all the same rules apply. So the first thing we're going to do is write f of x is equal to sine cubed of ln of x. Again, here it's not quite apparent what our inside and what our outside function is. But what we can do, as we did in the first example, is remove the exponent from the trig function and put it on the outside of a big parentheses. So this is equivalent to sine of the natural log of x, all to the third power. So from here, it becomes more apparent that our outside function, the thing done to our big parentheses, is just x cubed. So g of x is x cubed. And then our inside function, h of x, is going to be whatever inside those parentheses, so sine of the ln of x. So now we'll first find g prime of x, the derivative of our outside function. So again, g prime of x we could find just by using power rule. We're going to take our 3 and multiply it to the front, and decrease our exponent by 1 to get 3x squared. And then we'll also want to plug in h of x, so we get g prime of h of x is going to be equal to 3 times the sine of the ln of x squared. So now we want to find h prime of x. And to do this, we're going to need two rules. We're going to need to remember that d dx of sine of u is going to be equal to cosine of u times the derivative of whatever that u function is. And then we're also going to need that the derivative of ln of u is equal to 1 over u times the derivative of u. We're going to need both of these rules in finding h prime of x. So now, again, we want h prime of x, so we're going to start with the sine. So we know that the derivative of sine is going to be cosine. So the derivative of sine of ln of x is going to be cosine of ln of x. And then it's going to be multiplied by the derivative, so d dx of ln of x. But now we have this rule down here for that. We know that the derivative of ln of x, so I'm just going to write this as an aside, is 1 over x times the derivative of x, which is just 1. So we find that h prime of x is going to be cosine of ln of x over x. And again, we get that just by taking the product of our first piece and our second piece. So now that we have g prime of x, g prime of h of x, and h prime of x, we're now almost done. We just need to write f prime of x is going to be equal to g prime of h of x times h prime of x, which here is going to be equal to 3. I'm going to rewrite this as sine squared of ln of x. And then that's going to be multiplied by the cosine of ln of x, all over x. And there's not really much simplification we could do here, so that will be our final answer. And we get that f prime of x is again 3 sine squared of ln of x times cosine of ln of x, and then that's everything divided by x. So this here would be our final answer. Now that we've worked through 3 problems on our own, here are some practice questions for you to try on your own. I will warn you, be very careful if you attempt problem 4, as it's a little bit easy to get lost in the trig functions. The answer to these questions will show up in 5 seconds. Okay, so the answer to the problem 1 is tangent x times the square root of secant x divided by 2. For problem 2, you should have gotten 3 times, now in parentheses, ln of 2x, close parentheses, squared, all divided by x. For problem 3, you should have gotten negative 4 over x times the ln of x to the 4th squared. And finally, for the problem 4, again, this one was a little complicated, you would get 2 cosecant squared cotangent x times cotangent of cotangent x times cosecant squared x. If you didn't get these, or your answer looks similar but not quite these, I would encourage you to try to see if they're equivalent. If not, feel free to leave any questions you have in the comments. Thank you so much for watching. Have a great day.